All right, so the last set of examples are going to ask us to sketch the graph of the given polynomial function. All right, so for number one, we're given the function f of x equal to x to the fourth power minus 3x cubed minus 4x squared. Okay, so there are a couple of things that we want to determine before we sketch the graph. Number one, we want to determine what the intercepts are going to be. So we want to calculate both the x and y intercepts. We also want to determine the multiplicity of the x-intercepts, because that's going to determine whether the graph touches or crosses the x-axis at those points. And then thirdly, we want to determine the end behavior of our given function. Okay, so let's do the intercepts first. So what we want to do is we want to attempt to factor our polynomial here. And when we look at this polynomial, we should see that it's factorable. We can factor an x squared out at the start, which leaves us with x squared minus 3x minus 4. And x squared minus 3x minus 4, that's factorable as well. That's going to factor to x minus 4 times x plus 1. Okay, so once we have that factored, we can now determine our x-intercepts as well as the multiplicity of each of those x-intercepts. Okay, so the first x-intercept I'm going to get by setting x squared equal to 0, which happens when x is equal to 0. So again, because I'm wanting to graph this, I want to write that intercept as an ordered pair. So that's the ordered pair 0, 0. And then because the multiplicity of that 0 is 2, it's even. That means that the graph is going to touch the x-axis at that point. So I'm going to put a t underneath that to represent that the graph is touching the x-axis at that point. Okay, second x-intercept is going to occur where the next factor, x minus 4, is equal to 0, which happens when x is equal to 4, which is the ordered pair 4, 0. And because the multiplicity of that 0 is 1, it has an exponent of 1. It's odd. That means that the graph is going to cross the x-axis at that point. And then the third x-intercept is going to be where the next factor, x plus 1, is equal to 0, which happens when x is equal to negative 1. So again, that's the ordered pair negative 1, 0. And because the exponent for that factor is 1, it's odd again. That means that the graph is going to cross the x-axis at that point. Okay, if we want to get the y-intercept, the way we algebraically find the y-intercept is we plug 0 in the place of x and solve for y. So that's going to be y is equal to 0, which again is the ordered pair 0, 0. And the last thing we want to do is determine the end behavior of our function. So the end behavior is going to be the highest degree term. So the end behavior of this function is going to be y is equal to x raised to the fourth power. So we know the graph of x to the fourth power is going to go up and to the left and up and to the right. Okay, so once we have that, we have everything that we need to do a rough sketch of the graph. So we're going to make a coordinate plane. I'm going to plot my intercepts. Okay, so we have x-intercepts at 0, 0. We have one at negative 1, 0. And we have one at 4, 0. The y-intercept is at the origin as well. That's 0, 0. And then we're going to go ahead and draw the end behavior of our graph. So the end behavior of our graph is going to look like this. And then the last thing we're going to do to complete this graph is we're going to use the behavior of our graph at the x-intercepts to finish the graph off. Okay, so we know the graph is going to cross the x-axis at negative 1, 0. It has to touch the x-axis at the origin 0, 0, and the graph is going to cross the x-axis again at the ordered pair 4, 0. Okay, so that right there is a rough sketch of the graph of our function. Now, when we get into calculus, like we're actually going to be able to do like much more detailed, much more accurate sketches of the graphs of functions of this type. Okay, I want you guys to give the second one a try, so go ahead and pause the video, give that one a try, and then turn it back on when you're done to check and see how you did. Okay, so the good news for us in number 2 is that this polynomial is factored for us already. So it makes it super easy to determine what the intercepts are going to be. All right, so the first x-intercept is going to be the value that makes the first factor 0, which is x is equal to 1, which is the ordered pair 1, 0. And then we want to determine if the graph touches or crosses the x-axis at that point. So because the exponent is 2, that means the multiplicity is even. And if our 0 has even multiplicity, that means that the graph touches the x-axis at that point. Okay, next x-intercept is the value that makes the second factor 0, which is x is equal to -3, which is the ordered pair -3, 0. And then because the exponent for that factor is 1, it's odd. That means the graph has odd multiplicity, and the graph crosses the x-axis at that point. And then when we look at the third factor, x squared plus 1, it's not possible for that third factor to be equal to 0 in the real number system. Okay, so that part has no x-intercepts. Okay, if we want to calculate the y-intercept, we plug 0 in the place of x and solve for y. So that's going to make y equal to the opposite of -1 squared times 3 times 1, which is going to be the opposite of -1 squared, which is 1, times 3 times 1. So that becomes -3, which is the ordered pair 0, -3. All right, the end behavior, we're going to have to think a little bit about. So again, the end behavior is going to be dictated by the term of highest degree. So we want to think to ourselves, like if I were to multiply all of this out, so if I were to multiply out the entire polynomial, what would the highest degree term be? Well, we would take x squared and then take the opposite of it. So if I were multiplying this out, that would be -x squared times x squared. So the highest degree term, if I multiplied all that stuff out, would be -x raised to the 5th power. So that would be the end behavior of our function. And the end behavior of -x to the 5th is going to go up and to the left and down and to the right. Okay, so once we have all that stuff, we have everything that we need now to sketch our graph. So we're going to plot our intercepts first. So we have x-intercepts at 1, 0, which is right there. We have another one at -3, 0, which is right here. We have our y-intercept at 0, -3, which is down here. And then we have the end behavior of our function, which is looking like this and this. Okay, so we're going to piece that graph together by using the multiplicity at our x-intercept. So we know the graph crosses the x-axis at -3. So it has to cross the x-axis here. And then it's going to pass through the y-intercept and then touch the x-axis at 1. Okay, so graphically, the graph of that polynomial function is going to look like so. All right, so that should be good enough to take you guys through the homework for section 2-2. All right, take care. We'll see you soon.